Hi students, we are next starting our new chapter 23. Okay, three-dimensional geometry. Okay, you have studied in this chapter in the previous year. Okay, so you are familiar with the word three-dimensional geometry. What does it means, and what are the main points you have to remember when a three-dimensional geometry. Yes, we hear a three-dimensional geometry. Okay, so let us recall some properties and that you have studied in the previous year. Okay, so yes, you have studied in three-dimensional 3D geometry in class 11, and the main points have been discussed here. So you know, in a three-dimensional geometry, three dimensions are there. Okay, so in two dimensions there are two dimensions. In x and y. Okay, x and y, we say x axis and y axis, that is the two-dimensional plane. Okay, that two-dimensional geometry. In three-dimensional we have an extra axis, which is the z axis, and which is imaginary. Okay, that is imaginary. We are imagining we have just imagining that there is an axis which is z. Okay, that is we can visualize something which is in three-dimensional shape. We can visualize a three-dimensional cube. Okay, a cube which is of three dimension. Okay, which is kept in a three-dimensional way in axis. That axis, z axis, is yes passing through the center. That is how you have studied. I think you have remembering that. Okay, so here there have been three coordinates, x, y and z. Okay, and any point, you have no any point, some p, which of they are of the perpendicular distances, and from the yes rectangular coordinates xy. Coordinates are xy, yz. Okay, xy, yz, xz, that are the coordinates. Okay, you know coordinates. What are coordinates? Okay, yes, that are the coordinates. So x, y, z are the axis. Okay, and x, y, z, x, z, that are the coordinates of any point. Okay, of any point, capital P, here it is given capital P. Okay, and which have capital P, they are the perpendicular distances from the P. Okay, that is shown in that figure, the 23.01. Okay, there has been given a point P. Okay, why it is a rectangular coordinate? Yes, these planes these planes have formed a rectangular shape. That is why. Okay, yes, a rectangular shape has been formed because the distances are perpendicular. Okay, these axes are perpendicular. That's why they are rectangular coordinates have been seen. Okay, there it is saying like that. And you know the equations of coordinate planes. Yes, in x, y coordinate plane, what is there? X and y is there, so z is 0. Okay, z is 0. So a point on xy plane is what is maybe the form? Yes, it may be yes x, y, 0. Some p, if a point is p is a point on xy, then that p is xy 0. And if x is z, then it is x 0 y, sorry, x 0 z, y is 0 there. And last is y z plane, there 0 y z, x is 0. So these are the equation. On xy, z is 0. On yz, x is 0. On xz, y is 0. Okay, yes. And next is equations of plane parallel to the coordinates. What may be the equations? Yes, parallel to. If you know, yes, you know, in two dimension, if a line is parallel to x, yes, a line is parallel to x, then that line is x is equal to some that line, that is y is 0, y is constant there and x is varying. Okay, y is not 0, y is constant there. Yes, y is not changing but x is changing. That is the parallel means. So the equation of a plane here is planes are there. Okay, so in plane, then x for xy plane, that is x is z is equal to c. Okay, so an equations of plane parallel to yz is x is equal to a. That is a constant. Z is not changing there. For x, y, z is not changing. So z is some constant. Say c. We are just assuming that it is c. And y is at plane, x is not changing. So x is equal to some a. That is the equation of the plane. Okay, you compare with the 2 dimension, then you will get it. And for x is that y is not changing. So y is equal to some b. So a, b, c are real numbers and they are constants. Okay, and that is the third one. And fourth one is equations of coordinate axis. That is yes, equation of x-axis. For x-axis y and z are 0. So y equals 0, z equals 0. For y-axis x is 0, z is 0. And for z-axis x and y are 0. Okay, yes. And the fifth one is the equations of lines parallel to the coordinate axis. That is if the line parallel to the coordinate axis. In the third one we have saying the coordinate plane. We have saying about the plane, equation of the plane, what we are saying. But if the line is parallel to the axis, what does it means? Yes, it is same as for x-axis. Yes, y and z may be constant. For y-axis, yes, for y-axis x and z may be constant, and for z-axis x and y may be constant. Maybe it is not maybe, is constant. Okay, sorry, it is constant. Okay, and next one is the distance formula. That is the distance between 2 points. If we have given 2 points have been given in a plane, then what may be the distance? Yes, it is a formula. Distance is always positive, so we have taking the modulus. Modulus of PQ. If P is a point x1, y1, z1 and Q is another point x2, y2 and z2, then the distance modulus of PQ is square root of x2 minus x1 the whole square, y2 minus y1. Corresponding coordinates are taking the differences and then squaring it and then adding and then finding the square root. Okay, it is it is you have studied. Okay, and if that is 2 points have been given in a plane, and then if that point is 2 points, one point is the origin, then what will be the distance? That is root of OP. That means O is the origin and P is the point. That is root of x1 square plus x2 square plus x1 square plus y1 square plus z1 square. Okay, that is the answer. And next is a section formula that all have been, yes, you have been studied. Yes, section maybe it is in the ratio m1 is to m2 if the coordinates are divided. Okay, the coordinates of the point which divides the join of the points x1, y1, z. That is in the figure you have been given 2 points have been given, A and B. Okay, and that point is divided, yes, divided into at the ratio m1 is to m2. Then what may be the section formula? Okay, yes, if the division is internal, if the division is external, 2 division has been given. Okay, this is the section formula. Okay, that is 4. Now, how will you find the angle between 2 lines? Yes, the angle between 2 intersecting or coplanar lines is already known to the student. I mean, you have studied, and we have defining between 2 non-intersecting lines, that is skew lines. Okay, that is the angle between 2 skew lines is the angle between two intersecting lines drawn from any point parallel to each lines. So you have to just remember what is the angle between two lines. Okay, that is given. You have to know about the definition. And direction cosines has been there. Okay, direction cosines means that coordinates have been given, and what is the cosine functions? Okay, what does the cosine functions means? That is the line OP means from the origin parallel to the line AB. There has been drawn a line on the XZ plane AB, and we have taken OP parallel to OP parallel to AB. Okay, and that OP makes angles alpha, beta, and gamma. Okay, in anti-clockwise direction. We always measure the angle in anti-clockwise direction around a point. So that is in anti-clockwise direction. Okay, alpha, beta, and gamma has been there, and which is on the positive axis, positive direction of OX, OY, and OZ. Okay, and cos alpha, cos beta, cos what may be the measures of cos alpha, cos beta, and cos gamma, which has been known, and these three cos functions are direction cosines. Okay, direction cosines, cos alpha, cos beta, cos gamma. These three cos functions are together known as direction cosines of AP. And then it is generally denoted by small letters L, M, and N. So L is cos alpha, M is cos beta, and N is cos gamma. Okay, so we have finding the measures, that is three angles has been making by the line OP, which is alpha, beta, gamma, and then we have taken the cosine functions, and those cosine functions are denoted by small letter L, M, and N. That is the direction cosines. Okay, and that alpha, beta, gamma are the direction angles. Okay, direction cosines are L, M, and N. Direction angles are alpha, beta, and gamma. Okay, and always that satisfy. Okay, yes, 0 less than or equal to alpha less than or alpha, beta, gamma less than or equal to pi, because cos function lies between 0 and pi. That is the reason. Okay, and some notes has been given in the above definition. The line OP has its initial point at the origin. If a given line does not have its initial point at origin, we can draw a parallel line same magnitude that has been the initial point at origin. If we have defining it as the origin, OP is defining, which is parallel to AB. If that OP is not parallel to, we can draw another line which is parallel to OP. Then we can find the angles. That has been the first. Okay, there are notes there. And next note is direction cosines. PO, opposite. Since PO makes angle pi, okay, that is pi minus alpha, pi minus beta, and pi minus gamma. That is the angles. If we take the opposite, PO, okay, PO, yes, and OX, OY, and OZ, that is pi is the small, the main, and then we have the minusing that. And cos of pi minus alpha, cos of pi minus beta, and cos of pi minus gamma, that are the direction angles, and direction cosines may be minus L, minus M, and minus N, because it is on the opposite direction. Okay, OP, opposite to OP, that is PO. Okay, yes, I think it is clear. And next is the axis makes angle 0, pi by 2, and pi by 2. That is of axis. What may be the angles of axis? X, Y, Z respectively. So the direction cosines of x axis are 1, 0, 0. Similarly, for y-axis and z-axis, that you have to be remembered. What should be the direction cosines of axis? For x-axis, it is 1, 0, 0. For y-axis, it is 0, 1, 0. And for z-axis, it is 0, 0, 1. That is the direction cosines. Okay, that is direction cosines. And next is some results for that. Okay, this may be helpful for solving problems. Okay, that is the first is if L, M, N are direction cosines of a line OP, where O is the origin and X, Y, Z are the coordinates of P, then X is L into R, Y is M into R, and Z is N into R, where R is OP. Okay, if we have take OP as R, then we can, yes, if we have given x, y, z as the, x, y, z as the coordinates, then we can use the equation x equals LR and y equals MR and z equals NR for finding x, y, z. Okay, yes, and there has been a relation between, what is the relation between the direction cosines? That is, yes, L, M, N. What may be the direction cosine relation between L, M and N? That is L square plus M square plus N square is equal to 1. The sum of the squares of the direction cosines are of a line. Okay, we have saying about the line is always 1. That is the relation. Okay, this relation is very important. Okay, second one, that is the relation. And direction ratios and direction cosines of a vector. We have always studied about vectors. So if r cap is AI, what is r cap? It is the unit vector. Yes, of unit vector coordinates have been there. AI cap, bj cap, and ck cap, which is maybe a vector, and the coefficients I, j, k. That is coefficients. What are the coefficients of I, j, k, a, b, c? They are the direction ratios of r, and direction cosines of r are given by a by root of a square plus b square plus c square, comma, b by root of a square plus b square plus c square, and c by root of a square plus b square plus c square. So if we have given a vector, you can find the direction ratios and direction cosines of that vector using these two. That is, the direction ratios are the coefficients of unit vectors, and direction cosines of that vector is this equation. Okay, that is an examples has been given. Find the direction cosines of the line 3, 4, 12. Direction ratios of the lines has been given. What is the direction cosines? Okay, you can just substitute the values and find L, M and N. Okay, this type of small questions has been given. Okay. And now the next is the direction ratios of a line joining 2 points. What is the direction ratios of line joining 2 points? There has been 2 points given, A and B. A is x1, y1, z1, B is x2, y2, z2. Look at that figure. Okay, 2 points has been given, and AL, look at AL and KM. AL and BM, AL and BM. 2 points has been joining A and B, then drawing perpendiculars, okay, from A and B to OX, which meet at L and M. Okay, and AK is always perpendicular to BM. AK is perpendicular to BM. Okay, so this is the construction, and then we can find the direction ratios as x2 minus x1 by 2 minus y1 z2 minus z1. This equation is the direction ratios, okay, of line joining 2 points. 2 points has been given, and if we join the 2 points, what is the direction ratio? X2 minus y1, x2 minus y1, x2 minus x1, y2 minus y1, z2 minus z1. That is the direction ratios. Okay, this is an important, this you have to remember all the necessary equations. Okay, these equations should be remembered. that is the and definitions. If we have given a definition, then that is important. If we have given the equation, you have to find many problems to be solved. Okay, solution, you have to find solution to many problems using these equations. And next is angle between two lines. How will you find the angle between two lines? That is L1 M1 N2 are Mn and L2 M2 N2 are direction ratio cosines of two lines, and that is given there. Okay, and OP1 and OP2, from the origin two lines have been drawn, OP1 and OP2. So two lines, we have get two lines, and it is through the origin. Okay, and that two lines make an angle which is theta. Okay, and OP1 is R1 and OP2 is R2. That is the distance. Okay, now R1 R2 and P1 P2 is D. This we are assuming. And then what is the distance? That is cosine formula. We have using cosine formula, that is d square equals r1 square plus r2 square minus 2 r1 r2 cos theta, and d square is r1 square that is given, and we have finding r1 r2, and substituting you get d square is r1 square plus r2 square minus 2 into x1 x2 plus y1 y2 plus z1 z2. And then we have combining the equations, you will get cos theta as L1 L2 plus M1 M2 plus N1 N2, that is sigma L1 L2. Sigma L1 L2. Okay, that is the equation, that is cos theta is L1 plus L1 L2 plus M1 M2 plus N1 N2, where theta is the angle between two lines. Then theta is cos inverse of that. Okay, that is the angle between two lines. And now the Lagrange's identity. This is also very important equation. Okay, that is L1 square plus M1 square plus N1 square into L2 square plus M2 square plus N2 square minus L1 N2 plus M1 M2 plus N1 N2 the whole square is M1 N1 minus M2 N1 square, N1 L1 L2 minus N2 L1 square plus L1 M2 minus L2 M1 square. Okay, this is the proof is not so much important, but you can just go through that. Okay, yes, this is Lagrange's identity. Okay, and now some conditions for perpendicularity and parallelism. Okay, first is, yes, if we have given lines which are perpendicular to each other, and then you know what is perpendicular? Yes, angle is 90 degree. So cos theta is 90, that is cos theta is 90 means cos 90 is 0. You know cos 90 is 0. Okay, so L1 L2 plus M1 M2 E plus N1 N2 is 0. Okay, that is cos 90 is 0, so the right side becomes 0. So L1 L2 plus M1 M2 plus N1 N2 is 0. So if we have given two lines, and two lines which are perpendicular, then you can find out if the lines are perpendicular by using this equation. And if that line are parallel, L1 by L2 equals M1 by M2 equals N1 by N2. That is the condition. Okay. Also L1 equals L2, M1 equals M2, N1 equals N2. Okay. And if A1, B1, C1 and A2, B2, 0 are direction cosines of two lines, and if theta is 90 degree cos theta, that is that equation sigma A1 A2, that is also 0. So A1 B1 A1 A2 plus B1 B2 plus C1 C2 is also 0, which is also the condition for perpendicularity. And if the lines are parallel, theta is 0 degree. Okay. Yes, it is just a note for you. You have to remember this perpendicularity and parallelism. Conditions for that. When will we say two lines are perpendicular and two lines are parallel? These are the conditions. Okay, and that is also the conditions for perpendicularity and parallelism. Okay, and equations has been given. Find the angle between two lines whose direction ratios are 2, 3, 6 and 1, 2, 2. So L1, L2, yes, that has been given. You have to find the direction and angle. Cos theta is sigma a1 a2 by root of sigma a1 square into sigma a2 square. That is, you have just studied in the previous page. Okay, that equations that equation should be remembered. Okay, if you have again direction ratios and direction cosines, two cases are been there. Okay, here the first is the direction ratios L1 L2 LMN, that is given. Okay, and then not is given the direction ratios. So if you have given direction ratios, use the not sections equations, and you have given the cosines, use the first two equations. Okay, that is cosines has been given, you have to use the first equations. Okay, I think it is clear. Yes, and these are the problem questions. Okay, using all these above mentioned previously mentioned problems, you have to do this exercises. Okay, that is for today's class, and I think all of you understood about the section. Okay, and two more sections has been given for you. Okay, today itself I will post the videos. Please go through this, and this section is easy for you because you have studied it in the previous classes, and also the new topics are just clearly given. Okay, you have to remember that equations and then apply. You have to know where should be applied that equation. That is just. So you have to do the workout problems. I didn't given the workout problems, all the workout problems. That means in the textbooks workout problems. So please do that, and the exercises you have to be practice it. Okay, because I think questions has been there. Okay, using this formula. Okay, sorry, using this formula you have to do this questions. Okay, so do all these exercises, and I think it will be easy for you. Okay, and if you feel any problem, please ask me. Okay, thank you, students.